Hello there, my name's Vince from My Mate Vince, and in this video today we're going to try and fix not one, not two, but three Nintendo 64 power supplies. So I think these are a little bit of a bargain. I got three of them faulty for £24.87 delivered, and guess what? They are actually faulty, which is amazing because I bought quite a few things recently and most of them are working. Now, this is what the Nintendo 64 should be doing. I haven't got it connected up to a TV yet, but when we turn it on, can you see we have a bright red light down here, indicating that power's going into it. This is my working power supply. When I plug in each of the others, nothing is happening, which is fantastic. Turn on, nothing, and nothing, which is so good. I hate buying faulty stuff that's working because it defeats the object of buying something faulty when it is working. So let's bring them over to the map. We'll go through them one by one. Will they all have the same faults, or will they have different faults? And by the end, will we have 1, 2, 3, or none of them working? Let's find out. Right, so I've labelled them all up. Start on 1, then 2, then 3. Now looking here, they look to be all the same, but I remember when I looked at Nintendo 64 a long time ago, that although the model numbers were the same on the power supplies, the insides of them from memory were different. These are all D63760, D63760, D63760. So now, I'm kind of hoping that at least one of them might have the fault that I found ages ago, which is where on the board that sticks up, the kind of feedback board, there's some gloopy glue on there from years ago, and there's 2 resistors under there. And it's very common for one or both of them to fail. And I think my mate Vince was the first person to find that, which is the only thing that I've ever done of any achievement. And since then, that video's gone on to help quite a few other people fix their power supplies. And when I did it, Gadget UK said, Vince, I think you might be the first person to see that. And I was like, ooh, kind of got excited. And I think I was. A couple of other people said that I must have copied it from somewhere, but I didn't. And also, there's no other evidence of that little fix, as far as I know, being found before. And I think I had to buy about 6 or 7 of these to find the same one that I could copy every single component, get readings from every single component to see where the fault was. And then I found these 2 resistors. On my one, it was just a 1, but a lot of people have problems with the resistor underneath. So every one of these might well have the same problem, or it might be completely different. Might be completely different, but yet all 3 of these may have the same fault. So it should be interesting. Now, I'll quickly say at the beginning, don't copy what you see in my videos here. Working on power supplies is obviously very dangerous. We have 240 volts going into it. I don't intend to be doing anything dangerous, but I might well inadvertently do something dangerous. So don't copy me. Take this purely for entertainment. I'm not an expert or a professional in these repairs. So now let's take it apart and see what's going on. So we're going to have various different voltages on here. I think it was 12 volts and 5 volts. So maybe to begin with, I can't remember the pinout. Oh, here we go. The pinout's here. Let's zoom in. Maybe we could see if there's any voltage at all. Spin it round. So this is the negative, these 3, 1, 2, 3, and then we have the top 2 are 3.3 volts, the bottom one here 12 volts. So let's see if we do indeed have any voltage. Maybe we've got 3.3 but not 12, or maybe we've got 12 and not 3.3. Imagine if all 3 of them had that resistor fault, and maybe the person selling these doesn't do soldering and might not have seen the video. Okay, so negative in here, and these top 2 are 3.3, so do we have anything? No. Do we have anything here? No. Do we have anything here? No. Right, completely dead. First things first, let's make sure it's not a fuse problem. .5 amp fuse. I'm not sure if that's correct or if it should be a 3 amp fuse. I can't see what the rating is on the input on the primary. Anyway, maybe that's correct. Right, not a fuse problem. So let's open it up and see what's happening on the inside. So we're going to need a gain bit driver for these, and on the iFixit kit it's the bigger one out of the two. I'm pretty sure it's called gain bit driver. I'm not sure if this is a bit shallow or not, the gain bit driver, but it wants to keep skipping. So I'm having to use a lot of force down so it doesn't skip. Obviously I am unplugged, but we still will probably have voltage in here on the main cap, but we'll see what's happening. So now, where is the main? It looks like there's a massive cap here. So let's go across this one and see if we have any voltage, see if it's safe to work on. Can you see the big cap just here? I'm just going to go here and here. No, so I think I'm okay to work on, but there is voltage there, so it looks like maybe it was okay up till there. I can see a board here. I think this is the same as what I've worked on, because there's this feedback board going up here. I unsoldered all that before. So the very fact that there's voltage here and you can see it's dissipating now, I think that that side might, I think maybe there is voltage getting into that cap. Just going to short it, but there's nothing there anyway. Now let's see if this is the board that has the resistors in. Oops, gentle. Oh, it is, I recognise it already. I recognise it already, and I can see a big lump of gloopy glue. Now initially when I looked at this, it took me ages to go through everything. But next to this chip, there should be 2 resistors underneath that. I can't remember what they should be reading right now, but I can look back at my video. I think we're going to find that we have the same problem underneath here. But first things first, I think we had voltage in this cap, but let's just make sure that this 2 amp fuse here is intact. So I'm just going to go to continuity and go here. Fuse is okay. Right. So let's scrape away this and see if it uncovers 2 resistors underneath. So I suppose the resistor can't dissipate its heat because it's covered in this. There they are. I can see them. I think I need some sharper tweezers. I'm being gentle, I don't want to whack anything off the board. I think this might be just to steady this a little bit, to give it, because this is anchored down better, maybe to stop it wobbling around. I think before I might have put a bit of glue on top here. Right, I don't know what they should be, but we'll have a read, and if they're kind of in the meg ohms, it might mean that they're blown open. So what I did before is I measured this chip here, and I noticed that I think it was this top pin here was a different reading than the working board, and this top pin goes to this resistor here, and maybe, I'm not sure, I can't remember, maybe the middle pin goes to that one. So let's get our meter, multimeter. Let's see what we've got. So I'm on ohms, I'm just going to go across the top one. That might be okay, 222 ohms. Let's go on the underneath one. Don't think we're getting a reading on that underneath one. It's hard because it's still got gloop on it. No. So I think that's open. And I'm going to say from memory it was 1.5 thousand ohms, so 1500 ohms, but I don't know. So I'm going to get a pen and paper, I'm going to look back at my video and see what people said the underneath one is. So I think it's like 220 ohms and maybe 1500 ohms. So hopefully if we change that resistor out, the second one down, not the top one, the second one, we might be okay. Right, so the top resistor, this one here, is supposed to be 220 ohms, and the one underneath that I think this one is blown open is 1500 ohms. Interestingly, the model number here, I read out this one, is NUS-002UKV. Somebody said that that isn't a model number, this one here that I read out, this was in my previous video. They said that that's the postcode of where this is made. I don't know, not too sure, but anyway. Who knows? Apparently it's an 0603. So let's zoom right the way in and try to remove this. I don't want to have to get rid of all this board. What I'm going to do is I'm going to try to measure this out of circuit to see if the act of taking it out will somehow make it work again. Because one of the comments did say that the amount of power going through here would be so small it would be unlikely to generate much heat. In which case then, why have they failed by having the gloop on? It's too much of a coincidence. Loads of people have fixed these now with these two resistors under this gloop here. So I would say it's to do with heat being built up and the heat can't escape. But if it's not generating much heat, what is it about this that's causing it to fail? Unless, of course, it's something to do with this is having some reaction with the solder and it's not adhering properly to the board. Do you know what we could do? Let me get a... how about if I get my soldering iron on, I'm going to tap solder on each side in case it isn't the fact that the resistor's burnt out, in case it's that it's not soldered to the board anymore. So you can see it's open there. Well, it's not, it's 7.5 meg ohms. Let's give that a little tap. Let's zoom right away in and let's just see if we can get a bit of flux on it and give it a little tap. Let's see if it comes to life. Mind you, with my multimeter, you think it would be on the actual resistor rather than on the pad. You know, I think it'd be making a connection with the resistor. Can't really see what I'm doing. I don't think I've got any solder on that. Well, there you go, you can see that's melted there. I think I've moved that up ever so slightly. Let's just see now if we've got a reading on it. No, there you go, we're still in the mega ohms. Right, okay, what I'm going to do is let's get some low melt solder on that and let's take it off. Now, I'm wondering, really, I should be doing both of them, shouldn't I? It'd be nice to show one just for the video. I'll tell you what I'll do. Let's just do one for the video, but I think I really need to change both of them out. Because, or do I need to? I've already proved these are faulty. You know what? I'm going to change them both out. This should be 220, this should be 1.5K, and we know the top one is 220. But let's change them both out because if they've gone faulty, if the bottom one's gone faulty, how long is it going to be before the top one's gone? Right, and I'm going to get some wick and clean that up. Some solder wick. That's nice. And get some isopropyl alcohol and give it a nice good clean. So I'm using the Wonder stuff. Right, those pads look lovely. me get some resistors. Okay, so I've looked through my resistors, and these appear to be the same size as the one that came out, which is just here. I seem to have lost a 1.5 one. That's measuring 220 ohms. And if you have a look here, I've got 1K5 and I have got 220R. So let's give a little reading of these to see if they are similar. Now, if they were capacitors, it may not make a difference if it was slightly out, but because they're resistors, the path has to go through there. And if you think that when the leads are together, it's going to measure like 1 ohm or under 1 ohm. And if it's supposed to be 1,500 ohms, yet it's measuring, you know, like whatever it was, 6 megohms, then you can see that if it was like 1,000 ohms, it's going to be way more resistance. The path's going to be harder to get through. And then if you're talking about in the megohms, it's almost like a kind of blockage there. So I suppose the signal can't get through to go to that chip to tell it what to do. So if I was to go on here, let's just see if these are what they say they are. Yeah, there you go. Remember, that's K ohms, so 0.219 K ohms, which is 219 ohms, which is fine. And there you go, 1.49 K ohms. So nearly 1,500 ohms. Right, let's get those in. So what I'm going to do is I'm going to just put solder on one side, and I'm going to try to get them in with my tweezers. So if I put solder on one side, I can heat it up while trying to get them in place, and then that side's now set and the resistor's nice and flat, and then I can put solder on the other side. If I put solder on both of the pads, it's not going to sit right because I can only melt one pad at a time. Now the thing that makes this hard is because obviously it's awkward to get to, and it's super small. You know, these are super small. So I'm going to start on the bottom one. And if we have a look at this little SMD ruler here and go on to 0603 size, which also says 1608, you can see it fits there perfectly. There. So I'm thinking if I solder the right hand side first, I might be able to hold it in with that on there. So I'm going to use a little bit of flax and some leaded solder. There, do that one as well. Okay, let's try to get it in position. Oh, it's kind of small because it kind of wants to go sideways. Let's see if I can get it in. Is that on? Oh, hold on. That needs to go over more, I think. That is very awkward. Okay, that's definitely on. Now let's see if I can get the other side. Oh no, I got the one above it, didn't I? Whoa, that's a good blob. Did very well. Well done. Let's try to clean up that pad above it. That's clean. Let's see if I can get some of that off. Right, let's try that again. I'm doing good with the blobs. Remember, these can't short against each other. I'm going to try to bring the solder in from this side. I didn't think I'd find it so hard. In a way, my solder's a little bit big. And what have I got solder on the edge of that now? Oh, there we go. That's gone now. Let me give it a clean up. I think because it's all gone a burny, horrible mess, I think I'm struggling for the solder to stick to it. Right, let's put another bit of flux on. And I'm going to try to hold a soldering iron with my left hand and try to tap a bit on. Right, it feels so alien with the left hand. There you go. Right, that's on there now. Right, I'm just going to measure it off camera just to see if it's okay. Yes, it is, despite my burning. Right, now let's get a 220 ohm resistor above that. Right, I'm thinking this top one will be a lot easier. So let's melt this side here. Hold on, is these oh, I think my tweezers might be slightly misshapen. So that's why I think I might be struggling a bit more than I normally struggle. Also, I have got the shakes. There we go. Now let's try to get a little bit on this side. Okay, it's a bit blobby, but they're not shorted against each other. Let's give that a clean up. When I say a bit blobby, I mean massively blobby. If I added some hot air to that, it would probably sit nicer, but it's okay. They're in position. They don't need to look amazing. Part of me wonders how much heat I'd have to put on it to reflow that, because it is leaded solder. So if I was to put a little bit of flux on that now that it's clean and add the heat, I wonder would they sit nicer. I'm going to give it a go, because worst case scenario, I've got quite a few of these resistors and I can just do it again. I'm not intending to touch them, I'm just going to heat them up and see if they sit nicer. So I've got my temperature at, I'm going to have it at 450 degrees Celsius and 150 out of a possible 200 airflow. Let's see if they're going to flow nicely into place or not. There you go. The bottom one went. I presume the top one's done as well. Okay. Well, to be fair, they do look quite a bit better. I'm going to let it cool, give it a clean, and then I'll measure it. Right, so I'm going to go between the leg of the chip and the left hand side of the resistor. So I'm going to do the bottom one to begin with. So I'm on the middle leg of the chip and this side here. There you go, excellent, 1.5 thousand ohms, and the top one, brilliant, 220 ohms. Let's just make sure there's no short on top to bottom. 195, maybe that's through the chip or something. Go here. No, in the thousands. Yeah, okay. Well, they're not a direct short, so it must be okay. Right, so last time I used a little bit of hot glue just to keep that away from there, and I think a couple of comments came in saying bad idea to use hot glue on this here. I still haven't bought any silicone, even though I asked what I should buy and I was told what I should buy. I still haven't bought any. I'm wondering if I get a thermal pad and put it there, will that just keep it away from there to stop any chance of... but it doesn't look like there's anything on the back there anyway. See, I'm thinking if I use... I can't see that the hot glue is going to get hot enough to actually melt. And a thermal pad's not going to stop it from wobbling. So I think unless you had silicone, I think hot glue probably is the next best thing. So I'm just going to put a tiny, tiny, tiny little bit down the edge there, just to stick it into place. But yeah, you should be using some sort of silicone. Put a bit there, and here, let that melt in. Just let this set. Right, so I've wiped it all away apart from in that little cavity there. So if it was to melt, it's only going to go down on the bottom of the board there. And there's not a huge amount of it there. It'll probably only get to about here. So there we have it. I've cleaned it away from here and it's cleaned away from here. Let's put this back together and see if it's going to start working. It's lovely and easy to get into. Right, there you go. It's all back together. Let's plug it in, see if it's going to go bang. Well, let's see if we have the 3.3 volts and the 12 volts. Ready? Plugging it in now. We're in. Woohoo! Hasn't gone bang yet. So we have got here and here. Look at that. 3.5, bottom one, 11. I think there is ways that you can adjust it. I think I've seen it on Gadget UK's video. You can adjust the outputs. Oh, so that's a negative there. So we've only got one. Let me just go into a different negative, make sure. Got one 12 volt there, or 11 volts. 3.5, 3.5, and this one here. So it just goes to show you, it's definitely a common problem. And if I just changed the bottom resistor, it would have been fine. But I thought I might as well do two. Put down in the comment section why you think. We'll plug them in at the very end to make sure, obviously, it is working. I mean, plug it into the Nintendo 64. Put down what you think's happening there. I'm going to say it's heat related because you can see, if you look here, you can see the shape of the resistor in this thing here. So I'm thinking that it can't get rid of its heat. But then again, if it's generating so little heat, I presume it's this one here, you would think it wouldn't really make a difference. Or do you reckon it's having some reaction with the coating on the top of the resistor, which is getting rid of the resistance? As in some chemical. Do you think this is having some chemical reaction with it? Or do you think it's purely a heat dissipation thing? Anyway, let's move on to number 2. I think that one is going to be fine. We might have to open it up again to see if we can get 12 volts out rather than 11 volts, but I think it's going to be fine. Remember, it's not plugged into anything at the moment. Maybe when it's plugged in, we will have the 12 volts. I've got a feeling all of these are going to be the same now. Because if the seller sold it, he clearly didn't know about the, he or she didn't know about that resistor. Unless they're not able to, they might not have the equipment to deal with it. I suppose we should plug this one in to see if we have the 12 volts or the 3.3 volts. So 3.3, nothing. 12, nothing. Try a different negative. Still nothing. Still nothing. Completely dead, just like the last one. So I'm going to be careful taking this off because I've just had it plugged in. Make sure we have no charge in that capacitor, because those capacitors can still hold hundreds of volts even after it's been unplugged. Right, here looks like the same board again, because it looks like we have that top bit. So you can place your bets. Do you think it's going to be the same resistors again? There you go, 10 volts, and it's working its way down. So we know like the fuse and stuff's going to be okay because we have voltage here. So if I was to go here, you can hear it's okay. I know this is going to be the same. Now that I've said that, it won't be, but I know it is. So that's safe to work on now. We're at 4 volts. Let's just short that. I do have proper resistors to wear them down, but that's only 4 volts. So it's fine. Okay, we are safe to work on. Let's see if we got the gloop on this one too. Ta-da! Gloop again. I think it might have been these pots here that you adjusted to get the, you know, slightly higher or slightly less voltage. So I may have to adjust them to get more like 12 volts on the output. I'd have to watch Gadget UK 164's video. Chris has been a great help to my channel throughout the years I've been doing this. Do you know what I'm going to do? Before I do anything, look, can I see? Yeah, I can just see that resistor. Shall we see if I go through the very top to see if the top one is working okay? Look at that. There is nothing there. So this one, the 220 ohm resistor has failed. Look, there's nothing there. Right, let me pick it off. Let me fast forward through it all, and then we'll double check when this is off that it is the top one that has failed. But again, I'll be replacing both of them. Right, top one, nothing there. Completely open, so there's no signal getting through that. Bottom one. Bottom was okay, 1.5k. So it's the top one that's failed, the 220 ohm resistor. Let's take them both off. There's no point in me doing this in slow. I might as well just fast forward through it all. Same thing again, I'm going to use some low melt solder, take them off, clean them up, and get 2 new ones on. And then we'll see if the third one's going to be any different. So it's rinse and repeat like last time. I used a low melt solder and then I take off both the resistors. The difference is this time I don't lose the faulty resistor. So why don't we have a real close look at it under the microscope to see if we can see why is it failing. Is it completely burnt, or has this gloop had some sort of reaction and taken away the resistive layer? Let's have a close look. Right, so this is the underneath. And I'm thinking, obviously it's burnt because I've been, you know, I used solder to take it off, but I'm thinking that all looks okay. It looks like the ends are still on here. As far as I know with the resistors, I think that's just a little lump of, let's say, ceramic. And I think the resistive bit is the ceramic, aren't they? Because they're ceramic resistors, I'm sure. The resistive bit is the paint on top, as far as I know. So let's see. Can we see if the paint has been damaged once we take off this horrible grey stuff? Hold on now. Does that look a little bit blistered? Do you know what I mean? Does that look like a bit blistered up? I'm trying not to scrape too much. I'm just trying to get rid of this grey gloop. No, that looks like it's a sort of nice ceramic-y coating on it. So why on earth has that failed? Right, let's try to get a reading off that now in the thing, because as far as I can see, that solder looks like it's gone right up onto that black. There is nothing there. Right, what I'm going to do is I am going to get, so that's working. That's working. There's absolutely nothing there. Why, when you can see it hasn't eaten into it? I'm going to get a grinding pen. Now actually, I wonder, can I scrape? Oh, I'd love to know why this has failed. Clearly see that the coating's still there. Right, I'm going to get a grinding pen. I'm just going to tap it here and here to see if somehow that will liven up. I'm wondering if it's failed just where the solder meets this black resistive material. I'm going to be super gentle and just do it a quick little one. Just here. Right there. And there. Let's see if that's made any difference. Yes. Haha! We fixed it! We fixed it. There you go. 220 is perfect. 0.22. Oh my word. So do you know what? I haven't even added solder to it. So yeah, has it just somehow the grey stuff, because all I've done is that there and now it's working fine. Let me go across in a different position. Let me go right the way to the very edge. That's working. I reckon if I got rid of the gloop and hit it with my solder, my grinding pen, I reckon a power supply would come to life. Hold on, this might be actually useful for people that don't own soldering equipment. They might be able to just scrape it with a little sharp little knife or something to get it working again. Why on earth putting the grinding pen on that has that brought that resistor back to life? All I did was just went here and here. It was like I kind of took off a bit of coating and it started to work. How bizarre. Right, you know what we're going to do? If the same problem's on the next one, we're going to try to just temporarily fix it by scraping back. It's perfect. How bizarre. That's really interesting. Okay. Well, that's one for the comment section because I don't understand that. How does scraping a bit back make it work? I understand if I had to like resolder it, but all I did was scrape it back. Really is very bizarre. I've had it before with corrosion on a water damaged one where the resistor was no longer making contact with the ends of the resistor, you know, the solder bits at the end. So the resistive material, the solder had kind of been eaten away and it wasn't making contact with the resistive material. But here you can see the solder looks perfect. The resistive material looks perfect and it's got a big coating on it. So why, by using the grinding pen, does it suddenly bring it back to life? Very strange. Anyway, this one went on, these two resistors went on perfectly. If I had done this on the first power supply, you would be, wow, Vince is very good at soldering. But no, what you've seen was a blobby mess where it just kept going wrong and burning. And yet on this one, now that I'm fast forwarding through, it went lovely. Such is life. Anyway, let's give a shout out to the My Mate Vince Massive. They are the top level Patreons. So a massive thank you to everybody that supports over on Patreon. The members this month are Keymon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJVG, Pigsy, Ross Melanson, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, Garen Shaw, and Lady Leona Drury. So a massive thanks to each and every one of you. So I'm just going to cut now to when I've got this second power supply back together and we'll just do a quick voltage test to make sure it's working. But why wouldn't it be? We found a faulty resistor. We've changed out the faulty resistor. It's surely going to work. Okay, let's plug it in and see if it's number 2 is going to go bang. Plugging it in now. Good. Let's see if we now have voltage. Here, up top, we do. 3.5 volts. 3.5 volts. Boom, 11 volts. Excellent. that one there, and that one there. Okay, right. Hopefully when we plug it into the N64 it will work. Now let's do this one here. Hopefully it's going to be the same. And let's see if scraping back will work, because then that might make the comment section more interesting, because people might suggest why scraping back makes these resistors work again. Or was that last one just a fluke?
So I test this one for voltage, and guess what? No voltages either. I take it apart, and guess what? The circuit board's exactly the same on the inside. And guess what? The loop has covered 2 resistors, and one of them has gone faulty. The 220 ohm one's working, the 1500 ohm one is not. Now I do try to scrape it back with my tweezers to begin with, and it makes no difference. And then I get the grinding pen on it, and I grind either side gently, and it makes no difference. And then I go a bit more, and it makes no difference. And I go a bit more, and it makes no difference. So I don't know, when we were under the microscope, was that just pure fluke or what? I think maybe it might be failing just as the resistive material meets the solder. And when I ground back last time, I might have, because solder's very soft, I might have smushed the solder back onto the resistive material. For example, you know that kind of glossy coating on the resistive material? I would have ground through that with the grinding pen, and then by using the grinding pen I probably shoved the solder onto it, which started making a connection again. It's the only thing I can think of. And is it overheating that's causing it to fail on that joint, or is it some chemical reaction that's causing it to fail on that joint, with this glue being in contact with the resistor all that time? Maybe it has some reaction just where the solder meets the resistive material. Now I know that seems really odd, but if you think about cars, sometimes you have bubbling between aluminium and steel panels, where the aluminium meets the steel panel. I think it was on the Mercedes CL500 where the roof meets the kind of the C-pillar, where the C-pillar meets like the boot and the rear wing. I'm pretty sure from memory you get weird bubbling there, and it's not rust. It's some, is it called galvanic or something? I'm not sure. There's some reaction where you get dissimilar metals reacting with each other. So somehow could this glue have had some chemical reaction with the resistors? Because if they're not producing much heat, then you wouldn't expect them to burn out. And let's face it, that one we looked at under the microscope to me didn't look very burnt out. Also, I'm wondering with these, have they gone faulty since they were put away? For example, maybe they were working when they were put up in an attic, let's say 20 years ago, and being sat there for the last 20 years, they've had some reaction with each other. Because if it was heat related, they would have failed in use, not afterwards. And I'm thinking, would somebody be storing these power supplies if they were faulty? If they went faulty 20 years ago, you think they would have got them repaired then, or dumped the item then, rather than just putting it away in a cupboard and then selling it 20 years later? Obviously nobody knows the background of any product you buy on eBay, but I'm now wondering if it is some reaction more than heat. Anyway, let's go into the other room now and see, are these actually working on the N64? We know they're working with the multimeter. This one here is obviously working as well, just another faulty resistor. Let's see if they're actually working when we connect them to the Nintendo 64.
Right, here we go. I haven't plugged any of them in yet. Let's get it to the correct input. So it's just AV. So composite. Now, let's start with number 1. This one here. Right, here we go. Right, here we go. Oh, there we go. It's already on. I presume you have to have a game in here. I think so. Anyway, you can see the light there. Let me just quickly get a game. F1 World Grand Prix. Yes. Fantastic. There you go. Happy days. Right, okay. Let's do another power supply. Number 1 is working. Number 2 is working. Is it going to come up on the screen? Yes, it is. There we go. And third time lucky. I have confidence. I'm not going to lie, I feel quite smug, so I think I'm going to be quite irritating in this video, but I can't help it because that original video paid off massively. No. What? I spoke too soon. What? What have I done wrong with number 3? Shock horror! Number 3's not working. Oh, sorry. I somehow turned it off at the wall there and I didn't realise. Beg your pardon. I thought I was going to have to go and eat humble pie. The smugness is suddenly back. Come on. Come on, TV. You ready? Here we go. Yes. Light on. And there we have it. 3 out of 3. All because of, on each one, I know I swapped both of them, but 3 tiny resistors, 1 on each one. 2 of them were the 1.5k ones, 1500 ohms, and the other one was the 220 ohms. And I promise you, these things are so cheap. You get a whole kit of them from eBay. Well, when I bought them, I think they were like £5 or £6, something like that. Ah, there we go. Fantastic. Well, there we have it. Hopefully you enjoyed this video. If you did, give it a massive thumbs up, and I will see you again very soon. Still so smug. Thanks for watching.